going to talk about similar triangles. Okay, we're going to talk about similar triangles. Now, we've already talked about ways to prove two triangles similar, right? Earlier, a couple of weeks ago, we talked about a couple of postulates or theorems that we could use. What was one theorem that we learned that we can show that two triangles are similar? What'd you say? Angle, angle. We called it AA, similarity postulate. Do you remember that? And what we learned is if you have two angles in one triangle congruent to two angles in another triangle, that is enough to say that those two triangles are similar. Now, so we would say that these two triangles are similar by the AA similarity postulate because they have two angles congruent to two angles. And if I was to write a similarity statement, I would write something like triangle ABC is similar to triangle what? And does order matter, by the way?
Yes.
Okay, it does matter. What order would I need to write these next three letters in?
The way the angles correlate.
The way they correspond, right? Okay. So what I have A written first. Which angle does A correspond to? D. So D would be first over here. Then I went to B in this first one, and B corresponds to which one? E. So, and then that leaves F. So we have triangle ABC is similar to triangle DEF. Do you remember doing that? Okay. Now, we have two other similarity postulates. One that we actually talked about, not angle, side, angle, because why wouldn't we need to use angle, side, angle, you guys? Because there's angle, angle, and as long as you have two angles congruent, it really doesn't matter. You already know the sides are going to be proportional, right? So another one that we're going to use is, which one? Yeah, side, angle, side. And that one looks like this. Let's say I have these two triangles right here. And let's call this one RST. This one QXV. And let's say we had something like this. This angle R congruent to angle Q. And side RS congruent to side QX. And angle S congruent to angle X. Oh, wait. And by the way, oh, I'm sorry. That is angle side angle. Let's back up. And not only that, I don't need the sides to be congruent. I need them to be proportional, right? I'm getting a little ahead of myself. Okay. So let's back up here. Let's say I have angle S congruent to angle X. And let's say side RS was 10. And side QX was 15. And then let's say side ST is 12. And side XV is 18, something like that. Okay? First of all, I need to see if the two sides are proportional. What does it mean for two sides to be proportional? I mean, two sets of sides being proportional. Okay? I don't know that we really talked about this in much detail. That's right. Okay, we write a ratio. 10 corresponds, RS corresponds to QX. So 10 over 15 is one ratio. And a proportion is when you have two ratios equal to each other. What's another ratio I can write? What was that? 12 over 18, right? Okay. Now, are those two proportions equal?
Yes.
How can I check? There's two ways we could check. What's one way? What? Cross multiply is one way. I could go like this. 10 times 18 is 180. And 12 times 15 is 180, right? Is 180 equal to 180? Yeah, so I know that those are congruent. Also, what's another way? Okay, we can simplify each fraction. 5 will go into 10 and 15 both, right? It will go into 10 2 times. It will go into 15 3 times. What number will go into both 12 and 18? Okay, 6 will go into 12 2 times. 6 will go into 18 3 times. So they both reduce to 2/3. Therefore, we know that these two ratios are equal. And we call these two ratios a proportion. Okay? And we say that these sides are proportional. Everybody understand that? So, in the side angle side similarity postulate, if you have one angle in this triangle congruent to an angle in that triangle, and then by the way, this is the included angle, meaning it's between the proportional sides. And then you have two pairs of sides that are equal, or their ratios are equal, so they're proportional. Then we say that these two triangles are similar. Okay? So, by the way, triangle, I'm going to write this down. TSR is similar to triangle. What do you think? What order? VXQ. Okay? Because V corresponds to T, then X corresponds to S, and Q corresponds to R in that order. Okay, there's one more of these. Okay, what do you think the last one is? Side, side, side. Just keep in mind, you guys, any of the postulates we learned for proving two triangles congruent that had two angles in them, we're taking care of in the angle-angle postulate, right? So the last one we need is side, side, side. And that one just goes like this. Let's say that this side was 5, this side 10, this side, let's say 7, this side 14, and this side 9, this side 18. And let's call this triangle GHI, and this one JKL. All right. Now, this one right here is saying that if all, you really only have to check two sides, proportional, but if all three sets of sides are equal ratios, right? In other words, the sides are proportional, then these two triangles are similar. So 5 over 10, right, equals what? 1/2, okay, which is equal to what other pair of sides? 7 over 14 and what? 9 over 18, right? Are those all equal? They all equal 1/2? Technically, if you figure out two sides, well, no, yeah, all three sides would have to be proportional if you don't have an angle. Yes. That's why we have the side, side, side. Do we understand those, you guys? So I want everybody to write a similarity postulate for this one. Triangle what? I didn't write congruent on the last one, did I? Okay, good. Triangle what? HGI? HGI is similar to triangle what? J, K, L. Any questions there? Okay, now, one of your assignments today is to be able to solve some problems involving similarities like this. Now, sometimes you might have an X in there. I might have put an X on like this one right here. Instead of putting a 14 there, I might have put an X. How would you go about solving a problem like that? Okay, so we'd find the proportions of the two. We already know we have 5 over 10 and 9 over 18 is a proportion of 1/2, right? So could I write 1/2 equals what? 7 over what? 7 over x. Now, how does that help me solve this problem? I can cross multiply. 1 times x is x. 2 times 7 is 14. And that's what x is equal to. Okay? Do you understand that? Okay. So that's part of your assignment. Okay. For the other part of your assignment, we are going to need rulers. Okay, I'm going to give you guys some verbal instructions. I want to see who can follow it. Okay? I want you to draw a triangle. I would make it, you know, a couple inches by a couple inches somewhere on your paper. And I want you to use a lined paper like this because it will help you with what I'm asking you to do. Okay, you're going to draw a triangle, and you're going to draw a line or a segment that intersects two sides of the triangle but is parallel to the third side. I'll say that one more time. You're going to draw a triangle, and then you're going to draw a line that intersects two sides of the triangle and is parallel to the third side. For your parallel parts, I'd probably use these lines on the lined paper. That's why I'm telling you to use lined paper, to make sure they're parallel. Okay? I'll say it one more time in case you're confused. You're going to draw a triangle, and then you're going to draw a line through the triangle that intersects it twice. It intersects two of the sides and is parallel to the third side. Go ahead and do that. It does not need to intersect perfectly in the middle of the two sides. It just has to intersect two sides and be parallel to the third side. Okay, when you have it, raise your hand. Okay, it should look something like this now. I don't know if I like the yellow line. I got to get a different one. Okay, now that you have that, I want you to measure. I'm going to call this distance right here. I'm going to call this A, B, C, D, and E. I want you to measure distance AE, distance AB, distance ED, and distance BC, and distance EB, and distance DC. Measure each of those distances. I'll give you a minute to do that. To the nearest tenth of a centimeter. Now, I'm going to tell you guys, you have to be very precise. Like, you've got to be precise. And by the way, make sure that EB and DC are parallel. Make sure. If you don't have them parallel, go back and redo that. Use the lines on your paper to make sure they're parallel. Okay? And I want you to measure all those distances to the nearest tenth of a centimeter, or even to the nearest half of a tenth of a centimeter would be, if that's where it hits. Be very accurate. Okay, who thinks they were really, really accurate on this? Okay, Kai, we're gonna find out how accurate we're. Give me the number AE you got. I'm just gonna put those in mine. 3.7, okay. Keep in mind, you guys, that we drew different triangles, and so, you know, it's not gonna work out. It's not gonna, might not look to scale like what he did, so I'm just putting some numbers in. Okay, go ahead. What's ED? 3.5 centimeters, and you can already tell that my distance on DE is longer than EA, but then his distance is shorter, so he drew his line down a little bit lower than mine, okay? So just keep that in mind when we're doing it. Okay, go to AB. 2.5 centimeters, and BC. 2.5 exactly. Yours isn't going to be very accurate. I'm going to use someone else's numbers. Who's got one where your numbers are, well, no, I don't want one of those either. Who's got one where your line is closer to the top like mine? Or did most of you guys put it closer to the bottom? Okay, good. Give me your numbers. Give me EA. 3.6 centimeters. Give me ED. 5.4 centimeters. Give me AB. 2.5 centimeters. And BC. 3.8 centimeters. And even hers isn't the same scale as mine. Give me EB. Huh? And DC. 11.2. Okay, now this is what I want everybody to do on yours, just to see how accurate you are. First of all, let me ask you this. Well, let's do this first. Okay, I want everybody to divide. I want you to go AE over ED. And then I want you to see if it's equal to AB over BC. So everybody put those numbers from your triangle in your calculator. Well, go AE over ED. Actually, just list the numbers right there. So for example, AE on hers is 3.6 over ED, which is 5.4. That's equal to AB, which is 2.5, over BC, which is 3.8. Now, how can I check to see if those are equal or close? We just want them to be really close. Okay? Cross multiply, right? So, Kayla, cross multiply. 3.6 times 3.8. And then multiply 2.5 by 5.4. If yours are super close, that means you measured very accurately. Or you have a parallel line. What was that? Oh, 3.6 times 3.8? 13.68, okay. And then go 2.5 times 5.4. What is that? All right, you guys. Okay, let me have all eyes up here. I know you guys are doing your own, but look up here for a second. When we did Kayla's, 3.6 times 3.8, we got 13.68. 2.5 times 2.4 is 13.5. That's pretty darn close. Okay? Actually, they should be right on if we had accurate measuring tools, but because we're only measuring to the nearest tenth of a centimeter, we're going to be off a little bit, okay? But that's pretty close. What I wanted to show you guys is that these proportions are equal. AE over ED should be proportional to AB over BC. If these two lines, EB and DC, are parallel, okay? Also, CEB and DC. Okay, well, yeah, I'll get to that one in just a second. Okay, these right here are proportional. Okay, does everybody see that? How many of you got pretty close or on? Right on. Okay, good. How many were your proportions pretty close or right on? Okay, good. All right. That's one of the things we wanted to learn today. That these distances, AE over ED is proportional to AB over BC. Got it? Okay, and that's going to be true anytime when? When is that going to be true? When EB is parallel to DC. These two lines are parallel. Okay? All right. Now, also, erase these. How many triangles do I have here? 2, right? I have 2 triangles. I have AEB up here, AEB, and I have ADC. ADC. Now, if I take, and by the way, are these 2 triangles similar? Is there one of those postulates that we just talked about that would show that these 2 triangles are similar? What was that? Well, but that doesn't prove it yet. We have something to do with the angles.
Angle.
Why is it angle, angle?
Because it's parallel, so it's going to be the same angles like on angle B.
Exactly right. You guys, think of line DA as a transversal, and if these 2 lines are parallel, that's a pair of corresponding angles right there, and they're congruent, right? Also, over on the other side, these 2 angles right here are congruent. And yeah, and they share an angle A up here. Exactly. So angle A is congruent to itself. So by the AA postulate, these 2 triangles are similar. Therefore, what do we know about their sides? Their sides are proportional. So let's do a couple of sides. Let's do AE over, what side does AE correspond to? AD on the big triangle. Does everybody see that? And that's equal to what? AB over what? AC. And that's equal to what? This is the important one. This is the last one that confuses people. Huh? EB over DC. Good. Does everybody see that? Because all 3 of those ratios have to be congruent. Okay? So, therefore, if I was to write another congruent statement here, I mean, not a congruent statement, if I was to write some ratios right here, I could say that AE, which is, let's go 3.6 over D AD. What's AD? How long is AD, you guys? 5.4 plus 3.6 is 9, right? Okay, over 9. Whoops, I had my hand on there. Over 9 is equal to, let's do EB and DC. EB is 4.6 over 11.2, right? Okay, so I need to cross multiply and see how close that came to measuring on these, okay? So go 3.6 times 11.2 in your calculator. Let's see how close we were. 3.6 times 11.2, cross multiply. 40.32. And 9 times 4.6. Huh? 41.4? That's pretty darn close. Okay? Considering the tools that we were using, that's close enough. Okay? Those should be proportional. So, we're going to do a couple of problems on the worksheet together. Okay, everybody go to the side that says 9-3 first. On your worksheet that I just gave you, 9-3. Okay, I want you to look at number 1. Okay, everybody look at number 1. First of all, the instructions say determine whether each pair of triangles is similar. If so, tell which similarity test is used and complete the statement. So, in number 1, are those 2 similar? Okay, by what postulate? Side angle side. Okay, so on number 1, by side angle side, right? And if I was going to complete that congruent statement, it starts off triangle ABC is similar to triangle what? ZYM in that order, right? Everybody got that? That's how you're going to do one of those. Now, keep in mind the three postulates we learned. Everything has to be side, 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 side angle, side, or angle, side, angle. Oh, by the way, we should check the proportions on number 1. 6 over 12 and 10 over 20, are those equal? Okay, so make sure you check those when you do them, okay? Now, if they don't show that they're similar, just say not enough information not to know if they're similar. Just put, I either put not similar or not enough information, okay? All right, go down to problem number 9. Are those two triangles similar? By what postulate? Angle, angle, okay? And because we actually have 3 angles congruent to 3 angles, right? Now, I have to find an x and a y there, and I don't have 2 on one of the triangles, but since I know it's equilateral triangle, that one's a pretty easy one. What's the ratio right there? I mean, what is x going to be and what's y going to be, you guys? Y is 7. No, that one's a pretty easy one. Let's go to another one. Let's go to problem number 11. Are those two triangles similar? By what? Angle, angle, right? Now, or is that a 1 down in the corner by the 20? Or is there 2 of them? My eyes are bad, so I can't tell. Okay, so you get excuses when you get old like this. All right, so I need to, how am I going to find x in number 11? The sides should be proportional if the angles are congruent, right? So what is the ratio that makes them proportional? Okay, well, we could write x over 24 is equal to what? 20 over 30. What do you guys think? And I would probably reduce that to 2/3 because it makes it easier to work with, right? And how do I finish that? Cross multiply. So what would I do, Kyson? 3x equals 48, right? 2 times 24 is 48. What would I do next? And what would I get? 16. Okay, and there's my answer. Okay, do you guys know how to do that side? Okay, turn it over to the side that says 9-4. Okay, I want everybody to look at number 1. Number 1. MB. Look over there at MB. Over BA is equal to MD over, okay, DC. Everybody got DC? Okay, go to number 3. Number 3 is one I want to look at. BD over AC, number 3. BD over AC is equal to MD over MC. You guys, MC, because the answer to number 3 is MC. Because you look at, you guys, if you look at BD and AC, they're 2 different triangles, aren't they? These are triangles instead of cutting those 2 sides into proportional lengths. It makes 2 triangles. So BD is from the smaller triangle, AC is from the larger triangle. And then MD is the smaller triangle, and the side that corresponds to on the bigger triangle is MC. Got it? You understand that? So make sure you get those. Okay, everybody go down to problem number 15. Number 15. What is a proportion that I can write to solve number 15? 18 over 36. And Well, you could actually do it in a couple different ways. We could do 18 over 36 because 18 is the small side of the triangle over the other small side of the triangle, 18 over 36. And then we can do x over 50. Or, like you guys were saying, we could do 36 over 50, how you had it, is equal to what? 18 over x. I want you to see that either way we do this, you're going to have 18 times 50, right? 18 times 50 is equal to 36 times x, 36x. And down here, 36 times x, 36x equals 18 times 50. Do you see how it works? Either way, it comes out to be the same equation. And so when you solve for x, you're going to get the same thing. Okay, does that make sense? All right, that is your assignment. That's part of your assignment. I'm going to give you 15 minutes to work on this, and then I'm going to give you your other assignment. Okay, go. Okay, you guys, we are now going to learn how to use similar triangles to solve some problems in context, okay? So, how many of you guys have done this before? Okay, good. All right, so here's the sun up here shining. Can you guys see it up here? Kind of bright. And it casts this shadow down right here. That's my shadow right there, that big green blob. Okay? Okay, and it casts that shadow down right there. And we want to figure out, we want to approximate the height of the tree. Okay? So we're gonna call from here down, we're gonna call it H. And anyway, we have this tree coming down right here, and well, technically we need to draw our line in a different place. Okay. We are going to calculate the height of the tree from kind of where it hits the shadow right here. We're going to right here. Okay. So that's the height. Okay. And we can measure this distance right here. Let's say that that distance right there is 32 feet. Okay. And so we know those two things. Well, then we take a 6-foot person. Let's say you're 6 feet tall, and you are standing out here. Here's Kai right here. Oh, I've got to put some more muscles on him then. If it's Braden. I thought it was Kai, so at first. Okay. All right. Okay. So anyway, we have Braden out here, and Braden casts a shadow with the sun. His shadow is 5 feet. Okay. Whoops. 5 feet. And we know that he is 6 feet tall. And we can assume that he stands at a right angle to the ground. The same with the tree. Okay, right there. Because this is the ground right here. We can use what we know about similar triangles to solve this problem, can't we? Yes. What is a proportion that we can write to solve this? 5 over 32? 6 over h. Is that the only proportion we could write, or is there other proportions we could write? Okay. There's several of them that we could write. Okay. We could write h over 6 equals 32 over 5, and so forth. But they all come out to be the same when you cross multiply. 5 times h is 5h. So tell me what 6 times 32 is. 192. Divide by 5, and we get h equals what? What? 192 point? 38.4 feet. So we can assume that that tree is approximately 38.4 feet. Any questions on that? That is what you guys are going to be doing on your next assignment, so I will give that to you now.